simplify number 1. So how many z's do we have? No, don't say 2. 15, very good. 15 c's. So we did these. So we got negative 4 plus 4, which is 0. Or we can just leave it alone. It's 15z. Either way. Good. All right, on the next problem, how many h's does we have? Well, we got 3 here and negative 8 there. That'd be negative 5 h's. Very good. What about these j's? Oh, there's negative 2, and then there's positive 7. Gives us a positive 5 j's. Well, then we've got this 12 minus 2, which is a positive 10. Bam! This is done. Yes, it can be written in many different ways. Maybe you got 5j minus 5h plus 10, or something to that effect. Okay? Okay, so a rectangular yard is being separated into 4 equal size sections for different items at a yard sale. The area of the yard is 8x plus 12 square meters. See, and I understand, okay? Every one of you, when you look at your yard, it's 8x plus 12 meters, right? You don't calculate it in square feet or acres. It's 8x plus 12. Okay? No, 12. Okay? Make sure it's an even number. All right? I don't know what kind of nerd would look at their yard and say, wow, we cover an entire area of 8x plus 12. Okay? But clearly these people, clearly these people do. Okay? And that's okay because there's going to be some kind of purpose. All right? Well, here's the problem, is it's going to be split into 4 equal size. Okay, 4 equal parts. So what we have is you're going to take the 8x plus 12, and you're going to divide it all by 4. Okay? The problem is that looks really weird. Right? So here's the thing, is if you distribute the 4, this is what you would get. You'd get the 8x plus 12. The only difference is you're going to divide each term by 4.
Why do you divide it by 4? Oh.
Because we divided it by 4. Right? Well, what's 8x divided by 4?
2x.
2x's, right? Plus 12 divided by 4, 3. Okay? So how can you find, this is how you'd find the area of each section, which we already found to be 2x plus 3. When we explain our answer, we just need to see the work. Well, you can do this bottom part with all of these nice, pretty tiles, but we're not going to. All right? I'll show you the answers in a second. Now the thing is, though, with this 2x plus 3, how many of those sections were there? 4 of them. So this is the area of each section. This is the area of all of the sections. See, because now if we distribute the 4, we'd get what we started with. Yay! Yeah, I should point this out because I just don't understand. It should be labeled in meters squared, because it's area. All right. These are really nice, fancy terms that we use in math to confuse people, right? Like monomials. A monomial, well, some of you may know from English or science, perhaps. Mono is 1, the number 1. Meal is a fancy word to say meal, which is something you eat, right? Like lunch is a meal. And it means term. 1 term. Monomial. Eating 1 term. 1 term. Yes. Think of all of your favorite foods, like shrimp, or barbecued ribs, or hamburgers smothered with cheese
Yes.
and fry sauce.
Yes.
with nice crisp lettuce
Yes.
and a tomato with 3 layers of bacon
Yes.
and mayo.
And
Bam.
onion rings.
And you have a side of onion rings, right? With a
Fried chicken.
root beer on the side. Fried chicken covered in your favorite barbecue sauce and honey. Or your steak that is dripping with blood. I know some of you that's not working for you. So think of your favorite salad with all the greens and onions and radish eye.
Vegetables are nasty.
And it's covered with Thousand Island
What's your
dressing.
favorite?
Yes, spam, eggs, and ham.
What?
Rice.
Oh,
Okay.
School lunch.
Yes, or school lunch. Maybe that's your favorite. Okay, look. The only difference between monomials and non-monomials is when you start adding and subtracting garbage. Okay? Now it is no longer one term, it's 2 or more terms, right? All right, a factor. This is the real fancy way of saying a factor. Okay? It's just a bunch of products that make up a number, right? Like factors of 6 would be 2 and 3. Okay? Now, if you find that factors of a number are just 1 in itself, like 7, right? 7 can only be found by looking at whole numbers, of course. 1 times 7 is 7. Well, there's no other 2 whole numbers or integers we can multiply to get 7. So 7 is what we call a prime number, okay? So that's actually what we're going to be looking for, our prime numbers. Now that we have this example, let's look at different factors for these, right? Let's just focus on 24xm. Well, x and m are just variables, so they're good. Let's look at 24. Some of you may have seen this before. This is what we call a factor tree because it grows math fruit. Okay, and then you eat of it, and you partake of it, of the math fruit, and it will fill your soul with math. Okay? All right, so what 2 numbers multiplied together give you 24? Yeah, 6 and 4 is good. Did we have to use 6 and 4? No, some people may have used 2 and 12, or 3 and 8, or some other combination. It would be really weird. What about 6? Is 6 prime? No, it can be factored further through 3 and 2, or 2 and 3. Is 3 prime? Yes. 2? Yes. 4? 2 and 2 again. Very good. So if you can see, maybe some of you understand, if I took all these and multiplied them together, I would get 24, right? So I'm going to write these separately down here. 3 times 2 times 2 times 2. But I'm also going to include the variable x and m. A good point. This, on a problem like this, you would be finding the greatest G, common, C is for cookie, F, factor. Okay? GCF. It's like LCD, CD, PhD, MED, UOU, DMB, and all of those other, MP4. Let's look at 16 now. Well, the P and the M are good, but 16 is not. Let's factor 16. Very good, 4 and 4. Well, 4 and 4 can be split up, which we have already done. 2, 2, and 2. There we go. 4 2s. That's many 2s. 2 times 2 times 2 times 2 times P times M. Yay. All right, so it has come up that, well, why wouldn't we just use exponents? Because we want to write not so many numbers, because we're lazy mathematicians, right? Well, unfortunately, in this case, we would not. And I'm going to show you why in a second, all right? All right, so in this problem, we've got this 36 AM. Well, the A and the M are good, but 36 we should probably split up. So 36, 4 and 9 is good. Could use 6 and 6 as well. It's all the same. 2, 2, 3, 3. Hey, that's nifty. Yeah. All right. So we're going to write these down here. 2 times 2 times 3 times 2 times A times M. That's a good 3. That was a good recovery. Thank you. Well, let's look further into this. Now that we have all of these factors, we need to find the greatest common factor. So I'm going to put a line under here so it's separated. Okay. Well, what's our first common factor? Well, it looks like we've got these 2's are all common, right? So below that I'm going to write this 2, and this is all multiplication. Okay. Looks like we have another set of 2's. These 2's. So times another 2. Did everyone see? This 2, and this 2 are I used as a match. They're matches. I just curved it around, right? These are not ordered, but they are still matches. Okay. Well, is there any matches for 3's?
Yes.
Well, there is in 2 of them, but not all 3. It needs to match in all 3 terms. Okay. What about any 2's? Is there any more 2's that match?
Yes.
That are in all 3 terms? No, there's not. What about X, P's, or A's? No. But yes, that's very good. M's, we have this match. Now this is all multiplication, so our greatest common factor is going to be 2 times 2, which is 4 times M is 4M. Done. Bam. Heard of that before. Some students were saying maybe in 5th grade, the teacher said cross them out. That's fine. As long as you don't lose track. Okay? Now at the same time, I'm going to mention this because it's important for you to remember which terms were not circled. Just not right now. It's important in about 5 minutes. Okay? Yeah, yes, very good. So some of you may have noticed, yeah, there's a 4 here, there's a 4 there, and a 4 there. So we would know 4 would be common at least. Okay? But don't forget the letters. All right? Just be careful doing that because sometimes you'll miss some. All right? All right, let's look at some examples. Well, 54GH and 72G. Okay. Well, let's factor out this 54. All right, let's use 6 and 9er. 6. 2 and 3, those are prime. An old 9er. 3 and 3. Good. So I have 2 times 3 times 3 times 3 times G times H. All right, what about 72?
8 and 9.
8 and 9er. See, some of you would stop there, right?
No.
With the 8 and 9.
No.
So you'd say the 9's are common. Well, the 8's and the 6 have stuff in common as well. So 2 times 4, right? And 4 is 2 times 2. 9 is 3 times 3. Very good. So what we have is 2 times 2 times 2 times 3 times 3 times G. That was good. Okay? All right. So let's look at common terms. Well, there's the 2. 2. Let's circle these 3's just because we can. All right? 3's times. There's a G as well. Oh, there is another set of 3's. Let's circle these 3's. Well, what's 2 times 3?
6.
Times 3?
18.
18 times G? 18G. All right, let's look at this next one. Well, these numbers are very large, so it's more difficult, right? Maybe it is. I don't know. Let's find out. All right, 10 and 10 is good. You could use 25 and 4. 10 and 10 works. No, it's all the same. Oh, that'd be 2 and 5. Well, those are prime. 10, 2 and 5. Good. So we've got 2 times 5 times 2 times 5 times x times y. Old 75er. 25 and 3. Very good. Well, 3 is prime. 25? 5 and 5. That's very good. All right, so we've got 5 times 3 times x times y times z. All right, common factors. Well, let's circle them. 5's. 5's. X. twice. Bam. What's 5 times 5? Is there 2's in common?
Oh, wait, no.
It's a z, sorry. Yeah. 5 times 5. 25. Times x times y. Done. Well, now we have expressions, all right? This is going to work exactly the same like on this one up here. The only thing is now they put an operation in between like plus. Okay? You need to find the greatest common factor, and then we need to look at what's left. So let's look at this first one. 4x minus 7. Well, can I split up 4x? Yeah, 2 and 2, right? So 2 times x. We're going to just leave the operation. It's good. But what about 7? 7. All right, so what's common about these? None of them.
Nothing.
All right, well, if it cannot be factored, right, cannot be factored. Cannot be factored. CBF, right? LCD, GCF, CD, TGYF.
DLTs are good.
All right, let's look at one that will work. This one will work. Okay. All right, 30. Let's factor out 30. Two numbers multiplied.
10 and 3.
I think I heard 3 and 10. 3 is prime. 5 and 2, right? So you've got 3 times 5 times 2 times x. All right, so we've done the 30x, right? So that's the red there. What about 40?
4 and 10.
4 and 10 works. 4?
2 and 2.
2 and 2, good. 10?
5 and 2.
5 and 2. So I've got 2 times 2 times 5 times 2 times, nope, we're good. All right, so common terms, well, there's the 5s. There's the 2s times 2. Okay, this will give us our greatest common factor, which is 10. All right, so this is what you're going to do. Write the greatest common factor in front, 10. Then you're going to give yourself a set of parentheses. What's the operation in between? Minus. So let's put that in there. All right, so from the 30x, which is on the left of the minus sign, what was left over? 3 and x, right? Now this is multiplication, so it's 3 times x. 3x. What about what's left over from this 40? 2, 2, and that's it. 2 times 2 is 4. Done. We use the common numbers to find the 10. What was left over goes into the parentheses. Okay?
And you take the minus sign and the plus sign that was in the original.
Yep. Which may change in the future, but probably not today. Now, some of you may notice, and this is true, if you were to take this 10 and distribute it, you'd get the same thing you started with. This is a great way to check your answer. However, checking the answer takes so much time and effort and work that most of you won't do it. But I'm telling you this so that when you get on the test and you're like, I don't know if I'm right, then just check your answer by distributing into it, okay? And then you'll know, I'm right. She'll work though, okay? Notice on this one, it asks for just the greatest common factor. This one wants the expression. And they are different. We still found the greatest common factor in these ones. It's just we needed the rest of the expression as well. All right, so there's the answers. Let's look at these bottom ones, though, because now we've made it far more complicated because there's a fraction. Right? You see a fraction, and your brain shuts down, and you can't think anymore, which is good, because that's what math is for. All right, so here we have fractions, which make things extremely different. Okay? Not necessarily complicated, because there's a way to do it. You guys just don't know how, right? How do you find factors of 3/4? Uh-oh. Now we're in trouble, right? Do not use decimals, because there's no need. Let me show you, all right? So 3/4 x, what we really want out of this is a common denominator, all right? So if I have 3/4 x, what is my common denominator going to be? 4. Well, what I'm going to do is I'm going to take 24 over 1, and then I'll multiply both of these by 4. Hey, that's going to give me a common denominator of 4. Right? So minus, what's 24 times 4? 1, 2, 96. Good. That was close. Over 1 times 4 is 4. This is great because now we get rid of the fractions. It's so awesome. Right? If we got rid of this fraction stuff, well, then you guys would have it easy. Okay, well, let's do that. Okay, yeah. And that's going to give us, I'm going to do it down here, okay? So let's get rid of these denominators by putting it in front of print I, right? So see, this is gone now. We got rid of them. Factored it out. They were common denominators, common factored out. Okay? And what are we left with in the equation? 3x minus 96. I meant expression. 3x minus 96, right? Now your greatest common factor will be the denominator. I'm sorry. The numerator, which is the top number, right? Because that's the number that we need here. And then the leftovers stay in the parentheses, okay? Well, what's the factors of 3? None. It's prime. So over here we've got this 3x, right? Yeah. And we've got 96, which would be 23? 8 and 12. That's correct, actually. Very good. It's not the one I was thinking of initially, but that's very good. 8 and 12. 8. 4 and 2. 4. 2 and 2. 12. Sure, 3 and 4. 4. 2 and 2. Good. So now I've got 3 times 2 times 2 times 2 times 2 times 2. Did I get all those 2's? Yes. All right, so what's common here? 3's. 3 is common. That's it. All right? Where does the 3 go again? It's the numerator. Very good. But I still have to change all this stuff in here. All right? I keep the minus. So from the 3x, what was left over? X, right? This x. From the 96, what's left over? All of these multiplied together. 32. Bam. Got my answer. Nailed it. 3/8 x plus 18. What's the first thing we need?
Common denominator.
Very good. Common denominator. So this is going to equal, well, 3/8 x already has a denominator. Right? Plus, well, we need 18 to have a common denominator, so we're going to multiply it by 8 in this case, right? So multiplied by 8. It's over 1 times 8. 18 times 8. Big one. Wow, that was fast. Good job. 144 over 8. See, this is great because now we have 2 fractions which should release twice of that chemical in your brain to shut down, right? But this is good. This is what we wanted. We wanted that because now we can factor it out. 8. And what's left inside the parenthesis? Very good. You've got this 3x, right? Because this 8 is gone. Plus, yep, the 144, because this 8 is gone. 144. All right, let's start factoring then. So we've got 3x. 3x factors into, well, yeah, it's just 3x, right? Yeah. So 3x, 144. Sure, 12 and 12. Some of you were thinking 72 and 2, right? That's fine. All right. 12. 3 and 4. Some of you were thinking 6 and 2. That would work.
Don't circle 4.
Oh, my bad. Ignore that. perfect. Thank you. Yeah, 2 and 2, right? Very good. 2 and 2. All right, so let's write this out. 3 times 2 times 2 times 3 times 2 times 2. Yeah. All right. Well, 3's are common. 3. What else is common? None. So, where does this 3 go?
Above 8.
Very good. It goes above the 8, and then we need to figure out what we factored out. Factored out from there. So, we've got this 3/8, and what goes inside the parenthesis? Plus. Very good. What was left over from here was the x, so x. What was left over from 144? 2 times 2 times 3 times 2 times 2. 42? 9? 49. 48. Very good. Okay, in these 3 examples, again, all we're looking for is the GCF. What does GCF stand for? Greatest common factor. And C is for cookie. That's good for me. That's good enough for me. Okay. All right, do A. Find your greatest common factors. Okay, Carly's going to do A.
Okay, so for 12, then you do 6 and 2. I'm writing way too big. Oh, I did that wrong. 28, 7 and 4, 2 and 2. 2 times 2 times 7 times.
You said you're well, good. He's gone now. So
He calls me a blonde.
very good, Carly. Here are these for you to check your answers. Good job. All right, factored form is just this garbage that we did. All right, this is another form, another way to do this. They've got method 1 and method 2. Maybe you like this model stuff, okay? The model stuff can be kind of difficult. All right, try D, E, and F.